Hello there, and welcome to Simply About Earth, where curiosity gets cozy and wonder takes its time. Tonight, we're going somewhere that feels both impossibly distant and intimately close. We're going to look up, but not at the sky, you know. We're going to see the sky as ancient peoples saw it. Thousands of years before cities filled the darkness with electric light, before we lost the stars to our own glow. Before we begin this journey, I'd love to know where you're watching from tonight. Drop a comment below. Maybe you're somewhere you can still see the Milky Way. Or maybe you're in a city where finding even a handful of stars feels like a victory. Wherever you are, I want you to try something. Look up at your window or step outside for just a moment. Count how many stars you can see. Maybe a dozen, maybe 50 if you're lucky, 100 if you're somewhere truly dark. Now imagine thousands. Not scattered pinpricks, but rivers of light flowing across absolute darkness. Imagine the Milky Way so bright you could read by it. Imagine knowing every pattern by heart, because every clear night offered the same overwhelming display. That was the sky ancient people knew. And tonight we're going to explore how they understood it, without telescopes, without computers, without any of the tools we take for granted. They watched the heavens with nothing but their eyes and their minds, and what they achieved would astound us even today. So settle in, dim your lights. Let's travel back to a time when the night sky was truly dark and truly magnificent. The story begins 5,000 years ago in Mesopotamia. Picture yourself standing between the Tigris and Euphrates rivers in what is now Iraq. The sun has just set. Twilight fades quickly here, and when it goes completely. The darkness that follows isn't like anything most of us have experienced. There are no streetlights marking distant roads, no glow from nearby towns, no airplanes crossing overhead with their blinking lights, just darkness, pure and absolute. And then the stars appear, not gradually, not shyly. They blaze into existence by the thousands, whole constellations suddenly visible. As your eyes adjust, the eastern horizon glows with rising star clusters. The western sky still holds the ghost of sunset while stars already burn overhead. And that band of light, that river of milk, the Milky Way stretches across the entire dome of heaven, so bright it casts shadows on the ground below. This is what the Babylonian priests saw every clear night. This was their canvas, and they didn't just marvel at it. They studied it with the dedication of scientists, measured it with mathematical precision, predicted its patterns with accuracy that wouldn't be matched in Europe for thousands of years. The Babylonians understood something fundamental. The sky wasn't random, it wasn't chaos. It followed patterns as reliable as the seasons themselves. And if you watched carefully enough, if you recorded what you saw, if you thought about it deeply enough, you could decode those patterns. You could predict the future, not through magic, through mathematics. They divided the sky into 12 regions, constellations that tracked the sun's apparent motion through the year. We still know this system: Aries, Taurus, Gemini, names and patterns. They identified 4,000 years ago that we use today. But this wasn't astrology as we might dismiss it. This was practical science. When the sun moved into the constellation associated with spring, farmers knew planting time approached. When it entered the autumn constellation, harvest was imminent. The zodiac was a calendar written across the sky, visible to anyone who knew how to read it. The priests kept records. Thousands of clay tablets documenting their observations, planetary motions, lunar eclipses, the rising and setting of Venus, meteor showers, comets, anything unusual or regular in the heavens, found its way onto these tablets. They were baked hard by fires that destroyed the libraries, but preserved the tablets themselves, and they survive today, speaking across millennia, in wedge-shaped script, about the dedication of people who watched the sky with religious attention. They used base 60 mathematics, which we still use when we divide hours into 60 minutes, when we measure angles in degrees with 360 in a circle. These conventions come directly from Babylonian astronomy, from calculations they needed to predict celestial events. They noticed that planets, those wandering stars, moved against the fixed background in predictable ways. Mars takes 687 days to complete a cycle through the zodiac. Jupiter takes 12 years. Saturn needs 29 years. The Babylonians tracked these cycles with painstaking care. They noticed something strange. Planets sometimes appeared to slow down, stop completely, reverse direction for a while, then stop again and resume forward motion. This retrograde movement puzzled them, but they didn't let confusion stop their work. They recorded exactly what they saw. They measured the periods, they calculated when it would happen again, and they incorporated these irregular movements into their predictions. But their greatest achievement might be the Saros cycle. They discovered that lunar eclipses follow a pattern, a period of about 18 years, 11 days, and 8 hours, after which eclipses repeat with remarkable similarity. Think about what this means. If you observe an eclipse tonight, you can predict with confidence that another similar eclipse will occur one Saros cycle later. The Babylonian priests used this knowledge to predict eclipses years in advance. Imagine the power this gave them, the ability to announce months or years beforehand that the moon would darken on a specific night, and to be right, over and over again. This wasn't magic. It was mathematics, careful observation compounded over generations. But to people who didn't understand the system, it must have seemed like the priests could read the future written in the stars themselves. While the Babylonians were developing their mathematical astronomy, another civilization along the Nile was building its own understanding of the heavens. Ancient Egypt, where survival depended absolutely on accurate timekeeping, where the entire agricultural economy hinged on predicting when the Nile would flood. They found their calendar in the sky, specifically in one star, Sirius, the brightest star in the night sky. The Egyptians called it Sopdet and associated it with a goddess of the same name. Every year, Sirius would disappear from view for about 70 days as it passed behind the sun. And then, one morning before dawn, it would reappear, rising just before the sun, barely visible in the twilight. And within days, sometimes within a single day, the Nile would begin to rise. This wasn't coincidence. It was correlation born of centuries of observation. Sirius's heliacal rising occurs around the summer solstice, the same seasonal position that triggers monsoons in the Ethiopian highlands far to the south. Those rains send water northward to arrive in Egypt in midsummer. The Egyptians couldn't see those distant rains. They didn't need to. They had their signal in the sky. They built their entire civil calendar around this event. The rising of Sopdet marked the beginning of their year. They divided the year into 3 seasons of 4 months each: inundation, growth, and harvest. Each season triggered by the Nile's behavior, which was predicted by the stars. But Egyptian astronomy went deeper. They developed star clocks painted on coffin lids and carved into tomb ceilings. These weren't decorative art, though they're beautiful. They were functional astronomical tools. They divided the night into hours marked by the rising of specific stars called decans. 36 groups of stars, each visible for 10 days before the next group rose. This created a system that tracked both the hours of night and the progress of the year. Using these star clocks required expertise. You needed to know which stars to watch, to recognize them among thousands of visible stars, to understand how their rising times shifted throughout the year. Egyptian astronomers mastered this complexity, transmitted this knowledge through temple schools, maintained astronomical expertise across centuries. The tomb of Senenmut, architect of Queen Hatshepsut around 1470 BCE, contains one of the most complete astronomical ceilings ever discovered. It shows not just decans but planets, northern constellations including the Big Dipper represented as a bull's leg, Orion shown as the god Osiris, the goddess Nut arching across the sky with her body spangled with stars. This wasn't religious symbolism divorced from observation. It was astronomical knowledge expressed through mythological imagery. The Egyptians understood the sky both scientifically and spiritually. They saw no contradiction. For them, these were unified, complementary approaches to complete understanding. And then there are the pyramids. Those monumental structures built with astronomical alignments so precise, they still astound engineers today. The Great Pyramid of Giza, constructed around 2560 BCE, is aligned to the cardinal directions with an accuracy of better than 1/15 of a degree. Its north side deviates from true north by only 3 arc minutes, 1/20th of a degree. An error so small it's barely measurable even with modern instruments. But how? How did they achieve this without magnetic compasses, without GPS, without any of the technologies we'd consider necessary for such precision? They used the stars, specifically the circumpolar stars that never set below the horizon, stars that rotate around the celestial North Pole, forming perfect circles in the sky. By observing these stars throughout the night, marking their positions, finding the center of their circular path, the ancient Egyptians could locate true north with extraordinary precision. The pyramid wasn't just a tomb, it was conceived as a machine for resurrection. The pyramid texts speak of the deceased king ascending to the sky, joining the imperishable stars, those circumpolar constellations that never died, never disappeared below the horizon, that lived forever circling the celestial pole. The very stars used to align the pyramid became the pharaoh's eternal destination. Comment below and tell us where you're watching from tonight, and whether you can still see the Milky Way from where you live. Because what we're about to explore next, the astronomical sophistication achieved by peoples around the world, was built on something we've largely lost: access to truly dark skies, skies where thousands of stars shine clearly enough to reveal patterns, to tell stories, to guide navigation across oceans and continents. Across the Atlantic, in the jungles and highlands of Mesoamerica, another civilization was developing what might be the most sophisticated astronomical system of the ancient world: the Maya. They had no telescopes, no metal tools, no wheeled vehicles, no contact with old world civilizations, and yet they created calendars more accurate than those used in Europe until the modern era. They tracked Venus with precision measured in minutes over centuries. They built cities with astronomical alignments that demonstrate profound understanding of celestial mechanics. The Maya weren't just interested in astronomy, they were obsessed with it. Celestial events permeated everything: their religion, their politics, their warfare, their art, their sense of time itself. At the heart of their system was the long count calendar, a method of tracking time that counted days from a mythological creation date, August 11th, 3114 BCE in our calendar. This wasn't simple day counting, it was sophisticated, measuring time in nested cycles from single days to periods of nearly 8,000 years. They conceived of time as something that could be quantified and mapped with the same precision we apply to space. Time was a substance as real and measurable as distance. They interwove multiple calendars: the Tzolk'in, a 260-day sacred calendar used for divination and ritual timing; the Hab, a 365-day solar calendar governing agriculture and civil life. These interlocked, creating a larger cycle called the calendar round, 18,980 days, roughly 52 years before a specific combination repeated. This calendar round was profoundly sacred, its completion marked by ceremonies, by the extinguishing and relighting of fires, by the renewal of time itself. And then there was Venus. The Maya were utterly captivated by Venus, that brilliant planet appearing as both morning star and evening star, seeming to die and be reborn in predictable cycles. The Dresden Codex, one of only 4 surviving Maya books, is essentially an astronomical almanac, 6 of its pages devoted entirely to Venus. These pages track Venus's synodic period, the time between successive appearances in the same part of the sky. The Maya calculated this as 584 days. The actual figure is 583.92 days. They were off by less than 2 hours per cycle, less than 7 minutes per month. This is extraordinary precision for naked eye observation spanning years. But they went further. They recognized that 5 Venus cycles equal exactly 8 Earth years. 5 times 584 equals 2,920 days. 8 times 365 equals 2,920 days. This perfect commensurability allowed them to reconcile Venus observations with their solar calendar, and they kept going, discovering that 65 Venus cycles equal 104 Hab years equal 146 Tzolk'in cycles. These grand conjunctions were treated as profoundly significant, moments when different aspects of cosmic order realigned, when time itself renewed, when the universe confirmed its underlying mathematical structure. All of this accomplished using base 20 mathematics, vigesimal counting with dots and bars, and they used zero, that profound mathematical concept that allows positional notation. They developed it independently, creating a symbol that was both a number and a philosophical concept: completion. Ending, mathematics and philosophy unified in a single glyph shaped like a shell. But perhaps their most impressive achievement was understanding eclipse cycles. The Dresden Codex contains an eclipse table covering 33 years with corrections, allowing predictions to be extended indefinitely into the future. The Maya recognized that solar eclipses require specific alignments. Sun, moon, and Earth lined up just so. They understood that not every new moon produces an eclipse, because the moon's orbit is tilted relative to Earth's orbit around the sun. Eclipses only occur when these orbital planes intersect at precisely the right moment. They tracked these intersections with remarkable precision, developed warning periods indicating when eclipses were likely. Their predictions weren't perfect. They sometimes predicted eclipses that didn't occur, occasionally missed ones that did, but their success rate, achieved entirely through naked eye observation, remains impressive. For the Maya, eclipses weren't merely astronomical events. They were moments of cosmic danger, times when fundamental order seemed threatened. Solar eclipses, especially, when the sun disappeared in midday, were terrifying. The sun was a deity, a source of life and order. Its disappearance, even temporarily, suggested chaos, the possibility that cosmic order might fail. The ability to predict these moments gave astronomer priests enormous power. They could announce months in advance that the sun would be devoured, that darkness would fall at midday, and when the eclipse occurred exactly as predicted, when the sun returned just as the priests said it would, this demonstrated beyond doubt that they understood divine patterns. There's evidence they also understood precession, that slow wobble of Earth's axis causing star positions to shift gradually over thousands of years. Precession is subtle, takes about 26,000 years for a complete cycle, meaning the celestial poles shift by about 1 degree every 72 years. Barely noticeable in a human lifetime. Yet evidence suggests Maya astronomers were aware of this long-term cycle. They incorporated it into their long count calendar. The long count measures time in backtons, 144,000 days each, and structures these longer cycles in ways that seem to account for precessional movement. This is astronomy thinking in deep time, in cycles spanning thousands of years, treating the cosmos as a vast mechanical device whose gears and cycles could be understood, predicted, incorporated into a worldview that unified heaven and earth. The architecture tells the same story. El Caracol at Chichen Itza. The snail is essentially a stone telescope, its windows positioned to frame Venus's extreme northern position on the horizon. But El Caracol isn't unique. At Palenque in the jungles of Chiapas, the Temple of Inscriptions demonstrates even deeper sophistication. The temple has 9 levels representing the 9 layers of the underworld in Maya cosmology. On winter solstice, the sun sets in perfect alignment with the temple, disappearing into the architectural representation of the underworld, at the exact moment when the sun reaches its lowest point in its annual cycle. This wasn't coincidence. The Maya conceived of the sun's annual movement as a cosmic drama, a journey through celestial realms mirroring the human journey through life, death, and rebirth. Architecture became a stage for this drama, turning abstract astronomical patterns into concrete experiential rituals. At Tikal, one of the largest Maya cities, the entire central precinct is oriented along astronomical axes. The Great Plaza aligned north-south with precision, suggesting careful surveying. Temples on opposite sides framing solstice sunrises and sunsets when viewed from specific positions. The North Acropolis at Tikal contains dozens of temples built and rebuilt over nearly 1,000 years. Recent studies using LiDAR technology have revealed that many buildings are aligned not just to solar events but to Venus and specific stars, creating a three-dimensional astronomical observatory tracking multiple celestial objects simultaneously. At Uxmal, the governor's palace is oriented not to cardinal directions but to the rising point of Venus at its southernmost extreme. At Kopan's Stela, 12 marks where the sun crosses the horizon on summer solstice. And then there's the Pyramid of Kukulkan at Chichen Itza. During spring and autumn equinoxes, sunlight catches the stepped edges in a way that projects triangular shadows down the northern staircase, joining with the carved serpent head at the base, creating the illusion of a serpent descending from heaven to earth. This wasn't accidental. It was architectural astronomy, stone engineering that marks time through shadow and light. At Palenque, the Temple of Inscriptions has 9 levels representing the 9 layers of the underworld. On winter solstice, the sun sets in perfect alignment, disappearing into the architectural underworld at the exact moment when the sun reaches its lowest point. This wasn't coincidence. The Maya conceived of the sun's annual movement as a cosmic drama, a journey through celestial realms mirroring the human journey through life, death, and rebirth. Architecture became a stage for this drama. At Tikal, the entire central precinct is oriented along astronomical axes. The Great Plaza aligned north-south with precision, suggesting careful surveying. Temples framing solstice sunrises and sunsets. This astronomical knowledge held real power. Maya kings derived authority, partly from their ability to predict celestial events. Coronations timed to Venus appearances. Warfare scheduled for particular celestial configurations. The king wasn't just a political leader, he was an astronomer, priest, and intermediary between earth and sky. If you're enjoying this journey through ancient skies, take a moment to like this video. What we're exploring here, the depth of astronomical knowledge achieved without any modern technology, reveals something profound about human capability, about what careful observation and transmitted wisdom can accomplish across generations. Halfway around the world, ancient China was developing its own astronomical tradition, different constellations, different mathematical systems, different philosophical frameworks, yet achieving results equally sophisticated. Chinese astronomy is among the oldest continuous traditions in the world, with records extending back more than 3,000 years, and in some ways Chinese astronomers kept better records than any other ancient civilization. Their meticulous documentation of celestial events, comets, novae, meteors, provides modern astronomers with invaluable historical data. They recorded Halley's Comet as early as 240 BCE, creating a continuous record that has helped modern scientists refine their understanding of its orbit. But Chinese astronomy wasn't just record-keeping, it was deeply embedded in their political and philosophical systems. The Chinese conceived of heaven as a bureaucracy mirroring the imperial bureaucracy on Earth. The sky was divided into regions, each associated with different officials and functions. The emperor was the son of heaven. His authority derived from celestial mandate. Therefore, celestial events were political events. An unexpected comet wasn't just an astronomical curiosity. It was an omen, a message from heaven about the state of the empire, a warning that perhaps the emperor was failing in his duties. This gave court astronomers enormous responsibility. They had to observe carefully, interpret correctly, advise the emperor. A missed eclipse could be seen as professional failure, or worse, as evidence of cosmic disorder that might presage imperial collapse. The earliest Chinese astronomical records appear on oracle bones, pieces of ox scapulae or turtle shells used in divination during the Shang dynasty around 1200 BCE. These bones bear inscriptions recording celestial observations, eclipses, unusual star appearances, the beginnings of that continuous tradition. By the Han dynasty around 100 BCE, Chinese astronomers had developed detailed star catalogues. They identified circumpolar stars, created celestial globes showing constellations, built instruments for measuring positions of celestial bodies. They recognized 5 visible planets, associating each with one of the 5 elements of Chinese philosophy: wood, fire, earth, metal, water. They tracked planetary movements through a system of lunar mansions, 28 regions of the sky through which the moon passed during its monthly cycle. One of the most remarkable Chinese achievements was their recognition and recording of supernovae, stellar explosions so bright they can briefly outshine entire galaxies. Chinese astronomers recorded these as guest stars, temporary visitors to the permanent patterns of heaven. The most famous is the supernova of 1054 CE, recorded in Chinese, Japanese, and Korean texts. It shone so brightly, it was visible in daylight for 23 days, remained visible at night for nearly 2 years. Today, we can still see its remnant, the Crab Nebula, an expanding cloud of gas lit by the pulsar at its center. Without those Chinese records, we wouldn't know exactly when this happened, wouldn't be able to correlate historical observations with modern astrophysics. The Chinese commitment to recording everything unusual in the sky, motivated by belief in celestial omens, inadvertently created a database of astronomical events that helps scientists today understand stellar evolution and cosmic phenomena. While civilizations in Mesopotamia, Egypt, Mesoamerica, and China were developing their traditions using stone monuments and clay tablets and painted books, another group of people was developing an equally sophisticated system that required no writing at all: the Polynesians. Master navigators who settled the vast Pacific Ocean, traveling thousands of miles across open water to find tiny islands scattered across an area larger than all the continents combined. This wasn't primitive wandering. This wasn't accidental discovery. This was deliberate, systematic, scientific voyaging that required astronomical knowledge as sophisticated as any developed by any culture. Polynesian navigation, wayfinding, or Palu wasn't about following a single star or having a map. It was about reading the entire environment, sea and sky as one interconnected system, every element providing information, every observation contributing to a mental model of position, direction, distance. Navigators underwent training lasting years, often decades, beginning in childhood and continuing throughout life. They learned by doing, by sailing under master navigators, watching, listening, asking questions, experiencing, building an intuitive understanding that operated almost unconsciously. At the heart was the star compass, a mental construct dividing the horizon into 32 directional segments, each marked by the rising or setting point of a particular star. Not just any stars, specific bright stars whose rising and setting points were memorized, catalogued, turned into a cognitive map of directions. Imagine standing on a small platform in the middle of an ocean. You're centered in a circle, around you 360 degrees of horizon. At specific points on that horizon, specific stars rise and set. Arcturus here, Aldebaran there, Sirius at another point, Antares somewhere else. Each star marks a direction, each rising point a compass point, By memorizing which stars rise and set where, by recognizing these stars instantly when they appear, you can determine direction, maintain course even when the sun is down, and clouds obscure much of the sky. But stars move throughout the night, rising in the east, arcing overhead, setting in the west. So navigation required understanding not just which stars to follow, but when to switch from one to another, creating a mental sequence that worked through the entire night. You start evening sailing toward Arcturus as it rises. 4 hours later, Arcturus is too high. You switch to Vega, now rising where Arcturus first appeared. 4 hours after that, Vega is high. You follow Altair, and so on through the night, maintaining a constant bearing by switching between stars, always following the star that's near the horizon in your desired direction. This system had to account for seasonal changes. The stars visible change throughout the year. Earth's orbit around the sun means different constellations are visible in different seasons, so navigators needed different star paths for different times of year. The stars you follow in November aren't visible in May. You need a completely different set of guide stars, which means memorizing not one star compass but 12, one for each lunar month, each with its own set of rising and setting stars, each requiring recognition and recall. This is astronomical knowledge of profound depth, made more impressive by existing entirely in memory in oral tradition, preserved through chants and songs and practical instruction, passed from master to apprentice, never written down but never forgotten. But stars alone weren't sufficient. Wave patterns provided crucial information. Ocean swells, long-period waves, generated by distant storms or by wind patterns, travel in predictable directions. A skilled navigator could distinguish multiple swell systems, waves coming from different directions, and use them to maintain bearing even when skies were cloudy, even when stars weren't visible. Waves refract, bend, when they encounter islands, even islands below the horizon, creating interference patterns, disturbances in the regular swell pattern that indicate land ahead. A navigator who felt the boat's motion carefully, who paid attention to subtle changes in wave rhythm and direction, could detect islands from 20, 30, even 40 miles away. Beyond visual range, beyond any sight of land, clouds provided another layer. Certain formations appear over islands, cumulus clouds that build during the day as land heats faster than water, creating updrafts. These clouds are stationary or nearly so, while clouds over open ocean move with wind. A line of clouds that doesn't move, that persists in the same position, indicates land beneath them. Clouds also reflect. Lagoons with turquoise water cast a green tint on cloud undersides. Shallow reefs create distinct color patterns. A skilled navigator could see these reflections and know that land, though invisible over the horizon, lay in that direction. Birds provided yet another layer. Seabirds like boobies and noddies roost on land but fish far out to sea during the day. At dawn they fly out to feeding areas. At dusk they return to land, follow birds returning at sunset, and you're heading toward shore. Different birds have different ranges. Some fish close to land, others venture hundreds of miles out. Knowing which species go how far gives you an estimate of distance. Are you 20 miles from land or 100? The birds tell you. Brown boobies don't range far. Seeing them means land is near. White terns venture further, but seeing them means you're within range of an island somewhere. Navigators learn to read all of this simultaneously. Stars and swells and clouds and birds. Each source of information confirming or correcting the others, building confidence through cross-reference. You're following stars toward a target island, but wave patterns suggest you've drifted north of your intended course, so you adjust, sailing slightly south to compensate. Clouds on the horizon hint at land in a particular direction. Birds at dusk fly that same way, confirming what clouds suggested. You're close, you're on track. Throughout this process, throughout days or weeks at sea, the navigator maintains a mental map of the journey, tracking every course change, every drift, every correction. Dead reckoning without instruments, without charts, just memory and attention and accumulated knowledge. The sophistication is breathtaking when you consider the scale. They traveled from Southeast Asia to Easter Island, over 8,000 miles across open ocean, to an island only 15 miles across, finding it without instruments, without radio, without GPS. They reached Hawaii, the most isolated archipelago on Earth, over 2,000 miles from the nearest land. They settled New Zealand, Aotearoa, pushing south into temperate waters their tropical ancestors had never encountered, adapting their navigation to new constellations visible in southern skies, to different ocean conditions, different weather patterns. All of this intentionally, deliberately, not by accident, not by drifting aimlessly, by skilled navigation requiring astronomical knowledge as deep and practical as anything developed anywhere. European explorers couldn't believe it. Captain Cook was astounded by Polynesian navigators' ability to describe islands hundreds of miles away, to draw maps from memory, to explain sailing routes. But European scholars dismissed it, argued Pacific settlement must have been accidental, people blown off course by storms. How could anyone navigate thousands of miles using just stars and waves? Surely it was luck, chance. But the evidence is overwhelming. The settlement pattern shows intentional voyaging. Crops and animals brought to islands could only have been carried deliberately. You don't accidentally bring pigs and chickens and taro and breadfruit. Most convincingly, experimental voyagers using traditional techniques have replicated these ancient journeys. Maul Pialug from Satawal, one of the last traditionally trained master navigators, sailed the Hokulea from Hawaii to Tahiti in 1976, over 2,500 miles without instruments, proving what Europeans thought impossible was routine to ancient navigators. While Polynesians were sailing across the Pacific, other peoples were demonstrating astronomical knowledge through stone. In the Nubian desert, Nabta Playa, a stone circle older than Stonehenge, dating to around 5000 BCE, may be among humanity's earliest astronomical monuments. Standing stones arranged in a circle with sight lines to summer solstice sunrise and certain bright stars. Stonehenge itself, that iconic ring on England's Salisbury Plain, was built in stages over 1,500 years, beginning around 3000 BCE. Its primary axis aligns precisely with summer solstice sunrise. On the longest day, the sun rises directly over the heel stone viewed from the monument's center. This wasn't accident. The builders moved stones weighing up to 25 tons, some transported 150 miles, orienting their monument with astronomical precision. Stonehenge may have functioned as a stone computer for predicting eclipses. The 56 Aubrey holes, a circle of pits, is significant because 3 times 56 equals 168, close to the number of months in 9 years, a period relevant to eclipse cycles. By moving markers around these holes, tracking lunar cycles, ancient astronomers might have predicted when eclipses would occur. Newgrange in Ireland, built around 3200 BCE, older than Stonehenge, older than the pyramids, has a passage aligned so precisely that sunrise on winter solstice, and only on winter solstice, sends a shaft of light through the entrance to illuminate the inner chamber. For 17 minutes, the sun penetrates 60 feet of ancient corridor to light the back wall. This alignment still works perfectly after more than 5,000 years. Imagine standing in that chamber in darkness, waiting, and then seeing light slowly creep along the passage floor as the sun rises outside, until the chamber glows with warm light, only to fade again as the sun climbs higher. This was intentional. Architectural astronomy turning buildings into solar calendars, into temples where celestial events became tangible, experiential, sacred. Think about what Stonehenge required. It evolved over 1,500 years, But even the earliest phases demanded extraordinary effort. The first construction was a circular earthwork, a ditch and bank. Inside, 56 pits were dug, the Aubrey holes. These may have held wooden posts or stones for astronomical calculations. Later came the bluestones, 80 of them, each weighing up to 4 tons, transported from the Preseli Hills in Wales, 150 miles away. How did they move them? We can only guess. Perhaps on sledges hauled by hundreds of people, perhaps floated on rafts along rivers and coasts where possible, perhaps rolled on logs. Then the massive sarsen stones, 30 of them forming the outer circle, each weighing up to 25 tons, plus additional stones for the inner horseshoe arrangement, brought from quarries about 20 miles north. These weren't just moved, they were shaped, smoothed with stone hammers, fitted with mortise and tenon joints, where uprights would support horizontal lintels, and then raised. Imagine it. A stone weighing 25 tons, as much as 8 elephants, needs to be stood upright. Dig a pit. Tilt the stone toward it. Use ropes and leverage and hundreds of people pulling. Slowly, carefully. Raise it until it tips past vertical and drops into the hole. Pack earth and rubble around the base. Hope the stone doesn't crack. Hope it doesn't fall. And the lintels. Those horizontal stones sitting on top of the uprights, weighing 10 tons each. They had to be lifted 4 meters into the air, perhaps using earth ramps built specifically for each stone, perhaps using timber scaffolding, lifted inch by inch over weeks. All of this without metal tools, without wheels, without draft animals, just stone tools, wooden levers, rope and human muscle. Why? Why go to such extraordinary effort? Because the astronomical alignments mattered. Because marking solstices was important enough to move mountains, or at least to move hundreds of tons of rock. Because understanding celestial cycles was central to their world, their religion, their agriculture, their sense of order. The alignment to summer solstice sunrise isn't approximate. It's exact. Stand at the center. Watch the sun rise over the heel stone on June 21st. The geometry works. The angle is right. After 4,500 years of weathering, of stones shifting slightly, of earth settling, it still works. That precision didn't happen by accident. Someone understood where the sun rises on the longest day. Someone surveyed the site. Someone calculated where to place each stone, and then hundreds or thousands of people worked together over decades to make it real. Newgrange demonstrates even greater precision. The passage tomb is buried inside an enormous circular mound, 85 meters across, about 13 meters high, containing roughly 200,000 tons of material. The outer edge is faced with white quartz stones that would have gleamed in sunlight. Inside is a passage 19 meters long leading to a cruciform chamber. The passage walls are lined with massive stone slabs, some carved with spiral patterns, triple spirals, zigzags, designs whose meaning we can only guess at. The chamber roof uses corbelling, stones laid in overlapping layers, each projecting inward slightly, creating a beehive-shaped dome that has remained waterproof for over 5,000 years. This required understanding of structural engineering, of weight distribution, of how stones settle and compress over time. And above the passage entrance, the roof box, a special opening designed with one purpose, to let winter solstice sunrise reach the inner chamber. The builders had to calculate the sun's angle on that specific morning, design the roof box at exactly the right height and angle, orient the entire passage to line up, and then, after years of construction, wait for winter solstice to see if they got it right. They got it right. The light still penetrates to the back of the chamber, still illuminates the triple spiral carved on the back stone, still creates that moment of connection between celestial event and human-made space. Imagine being there when it was new. The mound gleaming white, the carved stones fresh, the chamber dark except for that one morning. You're inside with community members. perhaps priests or leaders, perhaps family members of someone buried here, waiting in complete darkness. And then a sliver of light, growing, crawling along the passage floor, slowly, so slowly, reaching toward you until golden light fills the chamber, illuminating the carved stones, making the space glow. For 17 minutes, the sun connects outside to inside, sky to earth, the cosmos acknowledging this human-made space, and then it fades, the angle changes, darkness returns. But everyone present knows the sun reached its lowest point. From tomorrow it begins its return journey north. Days will lengthen, spring will come, life will return. This is astronomy made sacred, science and spirituality unified, understanding celestial mechanics and honoring them with architecture that will last millennia. But to find the world's oldest astronomical tradition, we need to go much further back, much, much further. Aboriginal Australians have maintained continuous cultural traditions for at least 65,000 years. 65,000 years. Let that sink in for a moment. When the last ice age was at its peak, when Neanderthals still walked Europe, when much of the human population was concentrated in Africa, Aboriginal peoples were already in Australia, already watching the same southern skies, already building astronomical knowledge. Their star lore, embedded in songs and stories and ceremony, represents humanity's longest continuous relationship with the sky, and its sophisticated knowledge, not simple mythology, not primitive superstition. Aboriginal Australians recognized planets as different from stars, called them wanderers. They understood the Milky Way as a river. They observed and named dark nebulae, those clouds of dust that block starlight, seeing patterns in absence as well as presence. Think about that. Most people think of constellations as patterns made from stars, connect the dots in the sky. But Aboriginal astronomers saw something more subtle. They saw that the dark spaces between stars also formed patterns. That absence could be as meaningful as presence. The emu in the sky is the most famous example. A constellation formed not by stars but by dark clouds silhouetted against the Milky Way. It stretches across the southern sky. A giant emu visible in the dust lanes that block the bright galactic center. And its changing position throughout the year correlates with emu breeding season on Earth. When the emu in the sky is positioned a certain way, it's time to look for emu eggs. This is practical astronomical observation tied to ecological understanding. Calendar and guidebook written in darkness and light. Different Aboriginal nations across Australia developed their own astronomical traditions. The Yolngu people of northern Australia have complex star calendars indicating when certain fish are spawning, when turtles are nesting, when particular plants are ready to harvest. The Boorong people of northwestern Victoria had names for dozens of stars and constellations. They identified stars we call Arcturus, Antares, Sirius. They knew the Southern Cross. They recognized that some stars were actually distant galaxies. They called the Magellanic Clouds, those satellite galaxies of the Milky Way visible in southern skies, cooking smoke from a camp. Think about that. They looked at those hazy patches and correctly identified them as something different from stars, something more distant, more diffuse. Some Aboriginal traditions suggest knowledge of phenomena that seem almost impossible without instruments. Stories about the red giant star Betelgeuse appearing white in the past, which could reflect observations of long-term stellar evolution. Stars change color as they age. Betelgeuse is nearing the end of its life and may have been different thousands of years ago. Oral tradition preserving such observations across hundreds of generations seems almost incredible. Yet the persistence of Aboriginal culture, the emphasis on precise transmission of knowledge through song cycles and ceremonies, suggests it's possible. These songlines, song cycles that encode knowledge about the land, about navigation, about seasons, about stars, are remarkable cultural achievements. They're oral maps, navigational aids, astronomical calendars, ecological guidebooks, all wrapped in story and song and ceremony. A person learning a songline isn't just learning a pretty tune, they're learning how to cross country, where to find water, when plants fruit, how stars move, what weather patterns mean, all of it encoded in verses that must be remembered exactly, transmitted precisely. This is knowledge transmission at a level that demands respect. 65,000 years of continuous observation, of careful teaching, of maintaining tradition across more generations than any other culture on Earth. What's particularly remarkable is how Aboriginal astronomy developed completely independently, in isolation for tens of thousands of years, no contact with Babylonian mathematics or Chinese observations or Maya calendars, and yet arrived at sophisticated understanding, pattern recognition, practical application. This demonstrates something profound about human nature, about what our minds do naturally when given access to dark skies and sufficient time. We're pattern-seeking creatures. We can't help but notice, remember, systematize, build knowledge from observation. This isn't unique to one culture or one place. It's fundamental to being human. Aboriginal astronomy proves it. You don't need writing to develop sophisticated astronomical knowledge. You don't need instruments to track complex patterns. You don't need metal tools or agriculture or cities. You need dark skies, careful attention, respect for accumulated wisdom, and time, lots of time. 65,000 years of watching the same stars, of teaching the next generation, of refining understanding, of maintaining continuity across ice ages and climate shifts, and countless changes in the world below, while the stars above remained eternal. In the American Southwest, the ancestral Pueblones built structures aligned to astronomical events. At Chaco Canyon in New Mexico, the Sun Dagger site demonstrates remarkable sophistication, a sophistication that required not just observation but planning, not just knowledge but intention. 3 stone slabs lean against a cliff face at Fajada Butte. They look natural, random, but they're positioned, perhaps deliberately, perhaps discovered and understood, so sunlight passing between them creates daggers of light that mark the seasons with precision. At summer solstice, a dagger of light pierces the center of a spiral petroglyph carved on the cliff face. At winter solstice, 2 daggers frame the spiral on either side. At the equinoxes, a single dagger cuts through the spiral's midpoint. This is exact alignment, not approximate, not close enough, exact, requiring careful observation over years, deliberate positioning or selection of natural features, and maintenance over time to verify accuracy. Someone watched this cliff face throughout the year, noted where light fell on different days, carved the spiral in precisely the right place, or found the spiral already carved, and realized it marked these moments. Either way, this is astronomy made tangible. But Chaco Canyon's astronomical sophistication extends far beyond rock art. The entire ceremonial center seems designed as a calendar in stone. The major buildings, great houses like Pueblo Bonito, show orientations to cardinal directions and celestial events. Doorways aligned to solstice sunrises, windows framing solstice sunsets, wall alignments pointing to lunar standstills, those extreme northern and southern positions the moon reaches in its 18.6-year cycle, to the rising of particularly significant stars. The whole complex is an observatory, not a single building with a dome and telescope, but a landscape-scale instrument. Where you stand determines what you see, where you look determines what you learn. Kivas, those underground ceremonial chambers, often have features aligned to astronomical directions. The Sipapu, a small hole in the floor representing the place of emergence from the underworld, often aligns with the meridian. Roof openings frame specific celestial events. This suggests that ritual and astronomy were deeply intertwined. That emerging from a kiva might symbolize more than just coming up from underground. It might represent movement through cosmic time, through cycles marked by celestial events. from darkness into light, from chaos into order. Consider subscribing to Simply About Earth, where curiosity finds its quiet corner and wonder takes its time. These stories, these achievements of ancient peoples deserve to be remembered, understood, not as primitive superstition, but as genuine science. Different in method, perhaps, from modern astronomy, but not different in rigor, not different in precision, not different in the drive to understand. What we see across all these cultures, from Babylon to Britain, from Maya cities to Pacific islands, from Aboriginal Australia to ancient China, is a fundamental human drive, an irresistible pull to understand the sky, to decode its patterns, to find meaning in celestial motions. This wasn't unique to one civilization. It wasn't confined to one geography or one time period. Everywhere humans looked up, we wondered. Everywhere we had access to dark skies and enough stability to observe over time, we built astronomical knowledge. The details varied. The Babylonians used base 60 mathematics, while the Maya used base 20. The Chinese saw different constellations than the Greeks. Polynesian navigators memorized different stars than Aboriginal Australians. But the fundamental approach was universal. Watch carefully. Record what you see. Look for patterns. Test your understanding by making predictions. Refine when predictions fail. Build knowledge over generations. Pass it forward. This is science, not in the modern institutional sense, but in the most fundamental sense: systematic observation, pattern recognition, theory building, prediction and testing, transmitted knowledge. Ancient astronomers were scientists. They just didn't call it that. Without understanding celestial cycles, agriculture becomes guesswork. Without astronomical navigation, ocean voyaging becomes impossible. Without ability to mark time precisely, society remains disorganized. So astronomical knowledge became power. Those who held it, priests, navigators, calendar keepers, held positions of enormous influence. They could predict events others couldn't. They understood patterns others only dimly perceived. In many societies, astronomical knowledge was restricted, kept within priestly classes or royal courts. Knowledge of when eclipses would occur, when planets would appear, when the calendar needed adjustment. This could be presented as divine wisdom, a supernatural ability to see the future. But there's something deeper we need to consider. Ancient peoples didn't just observe the sky practically. They experienced it emotionally, spiritually, in ways we've largely lost. When you live under truly dark skies, when the Milky Way dominates your night, when you can see thousands of stars, when planets shine bright enough to cast shadows, the sky is overwhelming, beautiful, mysterious, eternal. Small wonder that nearly every culture saw the sky as sacred, as the realm of gods and ancestors. The stars weren't distant suns burning through nuclear fusion. They were divine beings, deceased souls, stories written in light. The line between astronomical observation and religious experience was non-existent. They were the same thing. Understanding the sky was understanding divine will. Tracking celestial cycles was participating in cosmic order. The Greeks synthesized much of this knowledge, creating the first geometric models of the cosmos, attempting to explain not just what happened but why, not just observing patterns but proposing mechanisms. Aristarchus of Samos around 270 BCE proposed something radical. He suggested that Earth and the other planets orbit the Sun, not the other way around. This heliocentric model was correct, but it wouldn't be accepted for another 1,800 years, until Copernicus rediscovered and refined it. Why did it take so long? Partly because it conflicted with common sense. The ground feels stationary. The sun appears to move across the sky, partly because it lacked a physical explanation for what held planets in their orbits, and partly because the geocentric model, with Earth at the center and everything rotating around it, worked well enough for most purposes. Eratosthenes, around 240 BCE, measured Earth's size with remarkable accuracy. He noticed that at noon on the summer solstice, the sun shone straight down a well in Syene, modern Aswan. No shadow, but in Alexandria, about 500 miles north, vertical posts cast shadows at the same moment. He measured the shadow angle, about 7 degrees, roughly 1/50th of a circle. If the sun's rays are essentially parallel, which they are coming from so far away, then that angle represents the curvature of Earth's surface between the two cities. 7 degrees is 1/50th of 360 degrees, so the distance between the cities, 500 miles, is 1/50th of Earth's circumference. Multiply by 50. Earth's circumference is about 25,000 miles. The actual figure is 24,900 miles. Eratosthenes, using nothing but simple geometry and careful measurement, came within 100 miles of the correct value. This is the power of mathematical thinking applied to astronomical observation. Hipparchus, around 130 BCE, made perhaps the most remarkable discovery of all. He compared his own star observations with records made 150 years earlier, and he noticed something strange. The stars had shifted, very slightly, but unmistakably. He had discovered precession, that slow wobble of Earth's axis that causes the celestial poles to shift gradually over thousands of years. Takes about 26,000 years for a complete cycle, meaning the pole star changes over time. Polaris is our current North Star, but 5,000 years ago, Thuban was the pole star, and 12,000 years from now, Vega will be. This is incredibly subtle, shifting by only about 1 degree every 72 years. To detect this, Hipparchus needed accurate star positions from well over a century earlier. He needed to trust that those ancient observations were reliable, and he needed mathematical sophistication to distinguish real precession from observational errors. He also created a star catalogue, the most comprehensive of the ancient world, recording positions and brightness of over 850 stars. This catalogue remained the best available for centuries. Even Ptolemy, 250 years later, relied heavily on Hipparchus's work. But perhaps the most astonishing artifact of Greek astronomy, of ancient technology generally, is the Antikythera mechanism. Discovered in a shipwreck off the Greek island of Antikythera in 1901. At first, no one knew what it was, a lump of corroded bronze and wood, but X-rays revealed something extraordinary. Inside were dozens of precisely cut gears, interlocking in complex arrangements, with Greek inscriptions describing astronomical phenomena. It's a mechanical computer dating to about 100 BCE, an intricate system of bronze gears housed in a wooden case about the size of a shoebox, and its purpose was astronomical calculation. Turn a crank on the side. Dials on the front and back display the positions of sun, moon, and planets, the phase of the moon, eclipses, even the timing of the Olympic Games. It models the irregular motion of the moon, the fact that the moon doesn't move at constant speed, but varies throughout its orbit. This requires a gear mechanism of remarkable sophistication. Nothing like it appears again in historical records for over 1,000 years. The mechanism demonstrates mechanical capabilities that seem impossibly advanced for 100 BCE. It required not just astronomical knowledge, which the Greeks certainly had, but advanced mathematics to design the gear ratios, mechanical engineering to conceive the three-dimensional arrangement, precision metalworking to cut the gears with sufficient accuracy, all applied to create a device that put the cosmos in your hands. Imagine holding this mechanism, turning the crank, watching the dials rotate at different speeds, seeing the moon's position relative to the zodiac, watching it slow down at apogee, speed up at perigee, seeing eclipse predictions appear on the back dial, knowing that this device compressed centuries of astronomical observation into mechanical form. It suggests something important. Ancient science was more sophisticated, more technically capable than we often assume. The mechanisms and knowledge existed to create devices we associate with much later periods. What we lack isn't evidence that such sophistication existed. We lack preserved examples. How many other devices like this were built? How much knowledge was lost when libraries burned, when civilizations fell, when continuity broke? The Antikythera mechanism is a reminder that human capability isn't linear, that ancient peoples were capable of extraordinary technical achievements, that what limits us isn't intelligence but accumulated knowledge, available resources, cultural priorities. Given sufficient motivation and resources, ancient peoples could achieve things we'd consider impossible without modern technology. They proved it with the pyramids, with Stonehenge, with Maya calendars, with Polynesian navigation, and with devices like the Antikythera mechanism that seem almost science-fictional in their sophistication. But for all the Greek achievements, for all their geometry and models and instruments, they still lack something ancient astronomers had in abundance: truly dark skies. By the Roman period, cities were large enough, lit enough with oil lamps and torches, that sky visibility was already decreasing. As civilization advanced, as cities grew, as artificial light became common, humanity's access to the sky began to diminish. What every ancient person saw, every clear night, started fading, first from the largest cities, then from towns, then from anywhere near human settlement, until now, in our modern world, the vast majority of people live under skies so washed out by light pollution that the Milky Way is invisible. Today, about 80% of Americans, over 60% of Europeans, live under skies where they cannot see the Milky Way, that great river of light that dominated every ancient night, that inspired countless myths and stories, that provided a constant reminder of cosmic scale and beauty. It's gone, erased by the collective glow of billions of lights. We've gained so much with artificial illumination, safety certainly, the ability to be active after dark, to work and travel and live without being constrained by sunset. These are real benefits, important benefits. But the trade-off, the cost, is higher than we often acknowledge. We've lost something profound, something that shaped human consciousness for hundreds of thousands of years. Most people living today will never see the sky as the Babylonians saw it, as the Maya saw it, as Polynesian navigators saw it from the deck of a canoe far from any shore, as Aboriginal Australians saw it in the outback before electric lights spread across the continent. They'll never experience that overwhelming river of light stretching horizon to horizon. Those thousands of visible stars revealing patterns so clear they seem almost to demand names and stories. The sense of being embedded in something vast and magnificent. Without that experience, without regular access to dark skies, astronomical knowledge becomes abstract, something learned from books and websites, something intellectual rather than experiential. Constellations become challenging to locate instead of obvious. The moon's phases require conscious attention instead of being impossible to miss. Planet watching requires planning instead of happening naturally whenever you glance upward. We've separated ourselves from something fundamental, from a relationship with the cosmos that every generation of humans maintained from the first emergence of our species until just the last century or so, until we filled our nights with artificial light and scattered the stars. This separation has consequences beyond just missing out on pretty views. The night sky shaped human cognition in ways we're only beginning to understand. Our pattern recognition, our sense of scale, our understanding of cycles and periodicity, our first mathematical thinking. When you live under truly dark skies, patterns reveal themselves naturally. You can't help but notice that certain stars rise together, that the moon goes through phases, that some stars don't twinkle and move differently from the others, that the whole sky appears to rotate around a fixed point. These observations required no special instruments, no particular genius, just attention and time, and from these simple observations, coupled with careful recording and mathematical thinking, came all of ancient astronomy. But if you grow up Never seeing more than a few dozen stars, those patterns aren't obvious. The sky becomes a scattered handful of bright points instead of a coherent display. There's less to notice, less to wonder about, less to try to understand. We can still learn astronomy. Obviously, we have better tools than any ancient civilization. We understand the universe in ways they couldn't have imagined. But we've lost the experiential foundation, the direct relationship, the sense that the cosmos is something you participate in rather than something distant and abstract. There's movement to preserve dark skies. Dark sky preserves and parks where light pollution is controlled. Campaigns to use better outdoor lighting that doesn't scatter upward uselessly. Education about what we've lost and why it matters. These efforts are important, not just for astronomy, but for maintaining some connection to the cosmos that shaped us, for giving future generations at least occasional access to the sky our ancestors knew. Because there's something profound about standing under truly dark skies, something that can't be fully captured in words or photos or planetarium shows. You have to experience it, have to let your eyes adjust, have to give yourself time to see not just the brightest stars, but the thousands of fainter ones that gradually appear. And when you do, when you stand there looking up at that overwhelming display, you understand something visceral about your place in the universe, about scale, about time, about the patterns that connect all things. You understand why ancient peoples devoted their lives to watching the sky, why they considered it sacred, why they built monuments and developed mathematics and transmitted knowledge across generations, why astronomical knowledge was considered the highest wisdom. Because it is, in a sense, not because stars control human destiny, but because understanding the cosmos, understanding our place in it, understanding the patterns that govern existence on every scale, this is as close as humans get to fundamental truth. And we risk losing access to that understanding. Not the intellectual understanding. We have that better than ever. But the experiential understanding. The felt sense of being part of something vast and ancient and ongoing. This is what we're losing to light pollution. Not just the ability to see stars, but a fundamental aspect of human experience that shaped our consciousness for hundreds of thousands of years. This is worth mourning, worth recognizing as genuine loss. That relationship with the sky shaped human consciousness for hundreds of thousands of years. It influenced our cognition, our pattern recognition, our sense of time and scale. Our earliest mathematical thinking developed partly through astronomical observation. Calendars led to counting systems. Tracking cycles led to understanding periodicity. Predicting celestial events required logical thinking, required record keeping, required what we now recognize as the scientific method. Astronomy was the first science. It was the first science because the sky is the most accessible natural laboratory. It's there every clear night, displaying phenomena that repeat, that follow laws, that can be observed, recorded, understood, predicted. Ancient astronomers proved that sophisticated understanding doesn't require technology. What it requires is attention, time, commitment to observation across generations, respect for accumulated knowledge, patience to watch the same skies night after night, season after season, year after year, lifetime after lifetime, building understanding slowly, incrementally, passing knowledge forward. They proved that human minds, given time and attention, can unravel cosmic patterns, can predict celestial events, can build knowledge that lasts thousands of years, can achieve precision rivaling modern instruments, can navigate thousands of miles, can align buildings to fractions of degrees, can discover mathematical relationships, can recognize long-period cycles, all without any technology beyond the human eye and the human mind. This should humble us, should make us reconsider assumptions about progress, about the relationship between technological sophistication and genuine understanding. Yes, modern astronomy has achieved things ancient observers never imagined. We've measured the universe's age and size, detected gravitational waves, imaged black holes, discovered thousands of exoplanets, looked back nearly to the Big Bang. These achievements required technology, but the foundation, the fundamental recognition that the cosmos operates according to discoverable patterns that came from ancient astronomers, from people who had nothing but their attention and their commitment to understanding. When you look up at the night sky tonight, you're participating in something ancient, something fundamental to human nature. You're doing what humans have always done, looking up, wondering, seeking patterns, building understanding. You are the heir to all of this, to Babylonian mathematics and Egyptian star clocks, to Maya calendars and Chinese records, to Polynesian navigation and Aboriginal songlines, to megalithic monuments and Greek geometry. Every time you know what phase the moon is in, every time you recognize a planet or constellation, every time you understand why seasons change or what causes eclipses, you're using knowledge built over thousands of years. Knowledge that began with people standing under perfect dark skies, watching, recording, remembering, passing forward what they learned. And perhaps, most importantly, you can still see what they saw. The sky is still there, waiting, unchanged in its essential patterns. Sirius still rises before dawn in summer. Venus still shines as evening star. The moon still waxes and wanes. The stars still wheel overhead in their eternal dance. If you can find dark skies, if you can get away from city lights, you can see the Milky Way. You can see thousands of stars. You can experience something approaching what ancient peoples experienced every clear night. That sense of cosmic vastness, of pattern and order, of connection to something larger than yourself. Rest now. Let your eyes close. Let the images fade. Picture yourself standing once more in that ancient landscape, 5,000 years ago. Darkness deepening as the last light fades. You're not alone. Others stand with you, gathered as they gather every clear night to witness the transformation. The brightest stars appear first, Sirius blazing in the south, Arcturus overhead, Vega to the north, and then fainter stars emerge, filling gaps, revealing patterns. Someone points east where a familiar constellation is rising. Its appearance marks a change in season. Someone else watches the moon, calculating days until ceremonies, until important decisions. A child asks about the stars. An elder begins to tell the stories. Not myths divorced from observation, but narratives that encode astronomical knowledge, that teach the patterns, that ensure the next generation will remember. This scene repeated across the ancient world, in different languages, among different peoples, but with fundamental similarities. Everywhere humans looked up, we watched, we remembered, we taught our children, we built knowledge across generations. In Mesopotamia, priests climbed ziggurats to observe. In Egypt, astronomers marked Sirius's rising. In Mesoamerica, Maya mathematicians calculated Venus cycles. On Pacific Islands, navigators memorized star paths. In China, court astronomers watched for comets. In the Australian outback, elders taught songlines spanning 65,000 years. And in the British Isles at Chaco Canyon, Nabta Playa, and 1,000 other sites, people moved massive stones to create monuments aligned with celestial precision. All of these efforts flow to you across thousands of years. You are the heir to humanity's longest continuous intellectual project, our collective effort to understand the cosmos we inhabit. And here's what remains most profound. It wasn't done for practical benefit alone. Yes, astronomy enabled better agriculture, navigation, calendars, but it was also done for something deeper. It was done because humans can't help but wonder. We see patterns and we seek to understand them. We observe regularities and we look for underlying principles. We witness cosmic majesty and we feel compelled to comprehend it. Not because understanding will make us richer, though it might, but because understanding is itself valuable, because knowledge is worth pursuing for its own sake. Ancient astronomers sat through cold nights watching stars, not because anyone paid them, not because it would make them famous, but because the sky called to them, because patterns demanded understanding, because humans at our deepest level are driven to know. This drive hasn't diminished. Modern astronomers still sit through cold nights, now looking through telescopes, still driven by that same fundamental curiosity, still building on foundations laid thousands of years ago. You carry this heritage. Every time you look up, every time you pause to watch the moon, or search for a planet, or trace a constellation, you're participating in humanity's oldest continuous intellectual tradition. You're doing what Babylonian priests did, what Egyptian astronomers did, what Maya mathematicians did, what Polynesian navigators did, what Aboriginal elders did, what the builders of Stonehenge did. You're looking up. You're wondering. You're seeking to understand. And in that seeking, you connect yourself to everyone who ever gazed upward and felt that profound mix of humility and exhilaration that comes from recognizing your place in something vast and ancient and magnificent. The stars ancient peoples watched still shine tonight. Sirius blazes just as it did when Egyptian priests tracked its heliacal rising. Arcturus guides just as it did for Polynesian navigators. Venus gleams just as it did when Maya astronomers calculated its cycles. The cosmos hasn't changed. The patterns remain. What's changed is our access to them through the light pollution we've created. But the patterns are still there, still following the same mathematical relationships, still displaying the same cosmic order ancient astronomers decoded with nothing but patience and attention. If you can, someday soon find a place away from city lights. Wait for a moonless night. Give your eyes time to adjust, 20 minutes or more. And then look up. Really look. Let yourself see, perhaps for the first time, something approaching what every human saw for the first 100,000 years of our species' existence. See the Milky Way stretching across the sky. See thousands of stars revealing patterns that seem almost obvious. See planets brighter than any star. See the cosmic display that shaped human consciousness. And when you see it, you'll understand something words struggle to convey. You'll understand why ancient peoples devoted their lives to watching the sky. You'll understand why they built monuments and kept records and developed mathematics and transmitted knowledge across generations. You'll understand because you'll feel it yourself, that sense of cosmic connection, that recognition of pattern and order, that profound awareness of being part of something vast and ancient and ongoing. You'll feel what Babylonian priests felt on ziggurats, what Egyptian astronomers felt tracking Sirius, what Maya mathematicians felt calculating Venus, what Polynesian navigators felt steering by starlight, what Aboriginal elders felt teaching star songs, what megalithic builders felt aligning stones. You'll feel what it means to be human, to be the species that looks up and wonders, that seeks patterns and builds understanding, that finds meaning in comprehension, that connects across time through shared observation of the same eternal sky. Sleep now with this knowledge, with this connection. Dream of stars blazing in perfect darkness. Dream of ancient peoples watching those same stars. Dream of knowledge building across uncountable generations. Dream of patterns discovered and preserved and transmitted forward. Dream of yourself as part of this great human project, this ongoing effort to understand the cosmos we inhabit. Dream of looking up and wondering, of seeking and finding, of the profound satisfaction that comes from comprehending even a small part of the vast universe we call home. The stars are still there, still shining, still following their eternal patterns. The knowledge ancient peoples built still informs our understanding. The wonder they felt is still available to anyone who takes the time to look up and really see. The connection they experienced across generations through shared observation is still possible, still profound, still capable of transforming how we understand our place in the cosmos. Good night, from Simply About Earth. Sleep well beneath the same stars that guided ancient astronomers, the same patterns that captivated human attention for thousands of years, the same cosmic order that continues unchanging and eternal, waiting for anyone who takes the time to look up and wonder.